Hello, and thank you for joining me for another Down and Dirty mini movie. We're up to video number 25 in our short film help series, where I try to bring you features of the Topcon product portfolio and demonstrate those to you. Today, we're going to be in Magnet Tools covering GPS processing. So we're going to be covering processing some raw GPS data. But the techniques for viewing the data, as long as they're geo-referenced, you could be viewing GIS data and or just real-time RTK data. Now, we're going to be creating a project with some proper setting techniques. We're going to be importing some raw data that you probably remember from video number 13. Not that exact data, but that gives you the idea of how to download the data. And we're also going to be bringing in data from the internet. We're going to be editing that point data real quickly, processing vectors, running least squares adjustment, doing point overlays in Google Earth and Bing Maps. Now this is just a demonstration of product features for training lessons. Visit Professional Services e-learning portal. They have great training lessons there, and then tons of great content on the My Topcon Now browser, or you can get that from the app. So let's get started. So we'll begin by going to the shortcut of Magnet Tools from wherever you have yours located. Now once we open the program, we're going to have a little bit of a wizard here that's going to, as you look here, ask us to create a brand new job. We have the option to jump right to a recent job. This is nice, so you don't have to sort through a lot of different jobs, especially in different directories. And you can open an existing job and search for it in different files and folders. Here, we're going to create us a brand new job. So for the job name, we've got to give it a name. We'll call it number 25. And you can set up a job location and create, a subdirectory by typing that information here. This is the Hall Farm. Who it's created by, keeps up with the date. And very importantly, depending on if you're running optical or GIS, you can save custom configurations. Now these are defaults. And just so happens this is the brand new version 7 of Topcon Tools. So we're going to choose GPS and take a look at what that has. We can change a lot of our display, our mathematical bearings, survey or mathematical, and then our precision units, and even our stationing. That looks good. We'll click Next. Since we're in GPS, we're going to be setting up a coordinate system. We can set up our own projection later, geoid files. Your time offset is very important for GPS if you're doing static occupation, so you know when you logged a file and so forth. Your units, linear units and so forth. This all looks good, so let's create this project. So we got a job created and we have basically just a blank canvas. Here's a couple of views of the data which we'll cover in just a second, occupation and observations. And this is your main workbook where we will be editing the data. So first thing we want to do is bring some data in. We can import it locally from these icons here under the Job tab. We can import it, and I'll show you that later, data from the internet. And then if you stored your data from Enterprise, click the Enterprise tab. But since my files are local, I'm going to go back to the Job tab and click Import. So in the Import tab, it's looking in a folder, and this is the information of some data that I have stored and we'll cover later, data sheets. I want to navigate to where my raw data is located. So I go to the Hall Farm raw data. All my data is empty, but I know the files are in there. And it's because it's looking for those data sheets that I looked for last time. And you can create custom file formats. But to change the format name that you're looking for, just hit the drop down. And currently I'm under the Coordinates tab. We're going to come down to GPS raw data. Now in the raw data format you have a lot of different options here. I would say most of the time you're going to be looking for TPS data, and that's directly out of a Topcon receiver. But the data I'm using for this tutorial is going to be this Rinex data. The data that I have is collected, or was collected, back in 2006, but it still serves its purpose for this tutorial. So I'll change this to Rinex, and notice now here are my Rinex files located. Now with a TPS file coming right out of the receiver, you'll just have one file. With my Rinex data, I have the navigation and the observation files. So for 5 GPS points, I will have a total of 10 files that I will be importing. And let's click open. So the data is populated, came in, and in our occupation view, this is a timeline of the receivers, which is pretty nice. This receiver was turned on around 2 p.m., started running, and then I turned this receiver on. I actually had 3 receivers out in the field. Started running it, and then a third receiver, and ran it going. Would toggle back over to the observation view, and this is a schematic, or basically the layout of those points. So the first point I occupied here, here, and this was the third point I turned on. Go back to here. After I ran the normal amount of time, I turned this receiver off and moved it to GPS 4 and turned it on. So the first triangle I surveyed was this long triangle here. Then I moved this receiver to here, ran another session, and created a triangle. After I was done, turned this receiver off, I moved it here and surveyed this particular triangle. This is just a demonstration. I'm not saying this is the correct way to collect data. This is an example. So I'm going to show you under the occupation view real quickly just some editing tools in Magnet Tools that we can do based on our occupations. Now notice this timeline down through here. Now one thing I would recommend doing is creating a site log. And let me show you an example. Here we have a site log sheet that you take out in the field with you, and you just put in the site ID of what you're going to name the sites, the antenna height in US feeder meters, and also vertical or slant, receiver ID, serial number, what you were using, the starting and ending times, and then also any notes of maybe the monument you were occupying, or you could even type in some instructions and so forth. Now back in Magnet Tools, you notice that we have pluses for occupations here. Once you expand that, Magnet Tools allows us to see each satellite 30, 24, 17, that you were tracking, and you have the options or the visibility to see if there's any cycle slips, and those cycle slips would be just breaks in the signal, but we track them pretty solid, so this looks like very clean data. You can go through all of them. GPS number 5, if we look at it, we do have a little bit of a couple cycle slips at the tail end of this occupation. Now if I wanted to remove that, maybe my residuals were a little bit high and I could see if this cleaned it up, I could highlight that and then right click and disable the epochs that was collected for that satellite for that period of time. This would just delete the whole satellite. I don't want to do that, so let's just disable that. And you notice that it's kind of hatched out. Now if you were experiencing a solar storm or something for a period of time and you wanted to, you could just block out that whole area if you had a bunch of cycle slips on all these satellites. You would just drag that window around that, right click, and disable that particular area. Alright, and we can just undo that and continue on. So now let's take a look at our workbook here. Here's our points tab, and this is our GPS points, and I can click on this name and sort them in the naming procedure that I collected. You have your latitude, longitude, ellipsoid height. We haven't defined any elevations or projections yet, so there's no elevation. Control, none of this is set for control. We'll take a look at that in a little bit. You have your antenna height, and then whether that's a vertical height that we can change. And this receiver was collected at a 1000 millisecond. That's basically a 10-second recording interval. Information about that and the number of epochs of data collected for each one. Then under GNSS observations, once we process our data, we'll start seeing some residuals at that point. Let's go back to GNSS occupation time, and let's set our antenna profiles here. Now, one thing I can do, since all the antennas are the same, is just highlight all of them, go to the very first box here, and then choose the antenna that I was using. So I'm going to say this was a Hyper-V receiver, and then just click anywhere out and it will populate the whole list. For the most part, all of these receivers were 2 meters. So I'll just type in 2.00, that's our units, and if you look right down here in the bottom right, you can see and verify that I'm in meters and so forth. We'll tap out of there, and then I do know that GPS 5, for example, was 1.794, and that was not a vertical height, it was measured as a slant height. I believe that's all I want to do under the GNSS occupations. We'll go back to points, and from here, if you just want to run this and process your vectors, you can do that without holding any control, and it will use one of these and then process from there, and keep the one that it does use just keeps the residuals at 0. Let's take a quick look at that. Let's just process the GNSS processes, and it will process the vectors up here. Alright, and this is what I was talking about. It held GPS number 2 with no residuals and then forced all the residuals to everything else. So standard deviation on this data is very, very solid, very good. We're looking at that. If you go under the GNSS occupations, it's not going to give us much here except some RMS values. And then very importantly, under the GNSS observations, we want to make sure that our solution type is a fixed solution. Now this is just L1 only data, not L1, L2. This would change depending on the type of data and the length of baseline that you're collecting. So magnet field is very flexible with that information. Now if you do want to hold control, you can go back to the points tab, and we could manually hold for control on any of these points that we know the known coordinates for, whether it's vertical only, horizontal, or both, and you can mix and match depending on where your control is located. So very flexible there. Also, by double clicking on a point, it brings up the point properties, and you could change that control here. Alright, and then also these are just autonomous coordinates. If you know the true value, you would edit that here at this time and then apply it. We won't cover all of this in this demonstration. So what we've got our residuals, everything looks good, but one other way is to look at loop closures individually here. If you go under the Reports tab, you can configure a report. Now here's some reports already set up, some adjustments and extensions. These are some defaults, traverse adjustments. Let's create us a new report and call this one GNSS loop closure. And then in the list here, there should be an option to do a loop closure. There we go. And we'll slide that over to the right. That's what we want. So let's hit close. So once we have our report configured, give it just a second here. Go to Execute Reports, and then these are all the reports that was defaults, and then I created this GNSS loop closure. So each triangle that I surveyed, this is your missed closure. So basically 3 centimeters in 1,300 feet in the total loop, 3 centimeters in this loop, and basically 3 centimeters in that loop. So that's just another great way Magnet Tools has to do quality control on your survey. So let's go back to the job, and let's go to job configuration now. We processed our vectors. We're very confident in the vectors themselves, but let's set our units to feet. We will set our coordinate type. Let's go ahead and set that at this time to NAD 83 2011 again for Tennessee state plane coordinates. Tennessee, NAD 83 2011, and then also set our coordinates to grid. Okay? So we have the option to display everything in grid in US survey feet. And again, if you need to edit this for the true value, whatever your control is, you can just double click and edit that. Once you're complete here, we always go back to process, and before you use any coordinates, always run an adjustment. And then it shows the adjustment, and you can print this information out. Okay, and then if you want to isolate that a little bit better, you can go to reports and just export points, for example, and then you can export the points this way in just a text format. You can cut and paste this into Excel or what have you. Now, before I can work in just a local system where I'm just on GPS North and a scale of 1 to 1 on the ground, I've got to basically kill this projection here. One of the easiest ways to do that is just come down to your toolbar right here, and when it shows the state plane coordinate value, if you can scroll down to the very bottom, you can set this to none, and then just check out here. So now we have a clean slate to work with. So this icon here allows us to create a brand new point, and I can just call this point number 1 or 1000. Doesn't matter, just give it a point number that's going to be local, and we'll just call this one 10,000, 10,000. And if you know and want to hold a certain elevation, let's just bump this up to 800 feet. And we'll leave the rest of this blank. Then we can hit enter. Alright, so now we have our local coordinate, and we're basically going to localize, as you've seen us do in other videos that I've done, let's say a 1-point localization. So the next step in my 1-point localization is just to decide which point that I want to make and merge with this. So let's just use point number 1. Okay, so we'll go up to process and choose localization. Now here we have another blank slate. We're going to add a point, and it's looking for a WGS point, WGS 84 point. So this is just one of our raw data points that we measured with GPS. So we'll choose GPS 1. For our local point, this is the point that we have the local coordinate values on, which is 10,000, 10,000, elevation of 800 feet. And we're going to use it for both horizontal and vertical. So we'll click apply, and it populates that information here, and then you can click OK. Once we're confident in this, all we have to do is click compute the parameters. And it does the datum shifts for us. There's no rotation from north, or your scale factor information here, and so forth. So here we can just click close, and now we have all of our coordinates in a local coordinate system. In this portion of the video, I'm going to demonstrate how to import data from the internet, and I've got a brand new job created with a blank slate. Under my job configuration, let me show you one thing here. I've set it up for my Tennessee zone that I'm working in. I want my datum NAD83 2011 geoid file and grid coordinates. Instead of recreating this every single time, I can save this configuration. And you remember in the beginning where I chose, GPS plus. I'm going to name this one GPS, or just call it maybe NAD 83 2011 Tennessee grid. And now, anytime I create a brand new job, I can choose this configuration, and it will bring in all the settings that I have before. So first off, I'm going to bring in the point that I collected. So I'm going to import I'm going to choose the extension TPS file. So here is the Hyper-VR that I collected an Opus solution on. It's got the extension of TPS. So it's bringing that in as a state plane coordinate in meters. Next, I want to bring in data that I want to post-process against this. And I'm going to get that from the core stations around me. So I'm going to go to Import from the Internet. Here's some search options to look for that data. I'm going to look for coordinates within a certain radius, kilometers. Now this information is read in from this particular file. Make sure you load your file first before you try to import any data. Otherwise it's not going to know where to look. So let's search. And now it populates all the core stations around me. Now this data was collected a while back, and we have precise ephemeris data. You do not normally see this unless you wait about 2 weeks to get the precise ephemeris data. So I have the option to pull that in. I definitely want to do that. So I'm just going to pick the 3 closest stations around me. These are sorted in order, and I'll pull in the precise ephemeris. And then we'll click Import Files. I've got an issue with point number 25 not coming in today. So let's go down to number 37 and let's grab this file and see what happened. Once they're imported, you can close out of this particular box. So just like before, we have our observation files from our core stations, and then here is our file here. Here's an observation view. This is not ideal. Number 25 was right down here. I had a better triangulation, but this will work for this tutorial. Now when this data comes in, I do not trust it to be loaded precisely, and it does not set the control as none. Now one trick that I do is I bring in the data sheets. So I'm going to go back to Import from a file, and I've got a folder called GPS Data Sheets. And if you're working in the same area over and over, it's good to go ahead and grab all these data sheets sometime and to store them, and then you always will have them. So the folder is empty, but again it's because it's not looking for the right extension. So I'm going to go to my Coordinates tab and come down to NGS Data Sheets. And I do have 34, 38, and do I have 37? No, I do not have 37. Well, let's go grab it real quick. So I've got 34 and 38. Let's go ahead and open them. And notice here it put a little different icon here, and it set the control for both, meaning it's holding them for both horizontal and vertical. This shouldn't take me just a minute. I'm at the ngs.noaa.gov website. I'll go to the cores. I'm going to type in 1037 and hit enter. Come down to the coordinates tab. I'm going to get the data sheet, and then we can just go to right click, and I believe we can do a save as. Yep. And I'll just save this file here really quick. Alright. Back in Tools, Import, datasheet number 37. It brings that in. Now we have control for it. We'll go up to Process, GNSS Processing. It says it processed 6 of 6 vectors. We have green all around. That looks really, really good. And we're holding control on everything. So your northing and easting and elevation standard deviations are basically less than 1 centimeter. So I'm very happy with that. So I've jumped back to the local job because I want to show you a demonstration of bringing this points into Google Earth, and since this is overlaid on a job that's more local, smaller, might look a little bit better. Now, one thing I need to do is, before I bring it into Google Earth, I need to set my job configuration back from not ground back to a regular datum. So I want to change this back. Well, actually, one of the easiest ways to do that is to go to my list of configurations, and that configuration that I saved before, just reload that and press OK, and now we're back to our state plane coordinates. So do that first, then we'll go to View, these points in Google Earth. Now you will have to have Google Earth loaded on your local PC if you've never loaded it before, and it should zoom right directly in. It looks like it's working. And this is the location where I used to live years ago. Here's my house up here where I had the one receiver set. And this field back here started out with point number 1, 2, 3, 4, and 5. So you can see how your points overlay on the property. Okay. Let's discard that data. And you can also see this information in Bing Maps and how that overlays. So looking at this in Bing Maps, once you choose that, it may look like nothing's happening, but if you go to the observation view, let's do that one more time. There we go. It will generate the view in this particular view here. So we can bring this information down. The nice thing about Bing Maps is it will show my vectors also, how they were collected. So thank you for watching video number 25, the Magnet Tools GPS processing. If you have suggestions for other demonstration video content, please let me know. Thank you.